Great. Hey everybody, hope you're all having a great day today so far. Well, been a pretty busy morning, but ready to get started. So you might have noticed on stream I finally have gotten little cute pixel avatars set up. It's just I don't know, just something I thought would be fun, maybe liven up the programming a bit. But anybody who stops in will get a little avatar, and you can customize it by spending well, you'll gain coins just from watching the stream. So if you want to do anything, just ask me about it, or you can type !avatar help to start getting that set up. But let's go ahead and jump into the programming, I think. Let me see. So we're trying to work on a new terrain system, and I've been thinking about it pretty much ever since last stream, how I want to set it up. And like ideally I would have a system that would generate what I'm calling the topology. I don't know if it's the correct term, but it would basically figure out the neighbors for every point, however many points are in a specific section of the mesh, and then also enough information to generate the placement and the triangles for every point. So for the placement, it's kind of easy. It just depends on the section type, and we would just give these lerp values and things like that. Triangles, it's a little more complicated, and it's almost like there's not really a good way to do it besides just either directly giving the triangles, or like determining the triangles at this point, or laying out the points in a certain predetermined order so that we can create the triangles how we want. And I keep going back and forth about which I'd rather do. If I have the points in a predetermined order, whenever we changed it, we'd have to go and pretty much change every system that deals with it, because then this placement info would be redundant as well. But at the same time, if I generate the triangles right here, I figure that this topology generator is just too big. So I'm kind of leaning towards the first section, which is, I don't know, I guess it's not that big of a deal. So I guess the topology would, but then, is it really, okay, well, let's see. For, I guess in general, this will specify the number and arrangement of points. So for a hex face chunk, maybe it would tell the max number of points on an edge. So that way we don't have to figure that out ourselves in other systems. And then I guess number of point rows. And then for our rectangle margin, it would give number of large and small rows. And I've kind of come to realize that this is probably not the best way to name them, because when I was looking at this diagram, I forgot to count these points. So I should probably add a point like right here. They're also not, I didn't number them right, so this code I did here is a bit wrong, unless I treat these separately. But so really these middle ones are kind of the larger edges, so I need to think of a different name. So it's really something like that. Okay, so why don't we just call them even and odd rows? Or I guess I could call it normal and offset rows because these are kind of offset. Or we could just say number of rows, and then the number of offset rows would just be the every other row. So number of points on standard rows, something like that. And then the triangle margins, I guess it'd be number of points on the triangle edges. Yeah, so I think this was kind of a nice idea because it like completely decouples the point generator doesn't need to have any knowledge of the topology at all except for what's given here, but I don't think it will really work because like there's no way to determine how I want the triangles to wind really, and we wouldn't have control over the pattern of triangles, so it might look messy. So I don't think this will work. It's just, even though ideally it would be perfect, it's not going to be practical. So if we're going to have this, and then I guess all points should be in a standard order. If we're gonna have this, then do I really need to have this neighbor graph? Because for instance, we can figure out, well, maybe it would still be useful. Okay, so for the neighbors of this, it would be kind of annoying logic, and well, maybe we will have a neighbor finder because that logic is going to be duplicated in the triangles. Oh wait, no, because the triangles, okay, that logic is only actually needed for normals because the triangles doesn't really care about neighbors. It just goes through the points as we've set up and calculates all the triangles, whereas the normal needs to get all neighbors. I guess that's kind of how we were doing it before, but the problem comes with how do we deal with neighbors outside. Well, that'd be fine because we'd know what kind of sector our neighbor is. I think. No, yeah, that would be possible to find out. That's a good question. Now I think about it. So I want to have some way to figure out the points in our neighboring sectors. And so I guess one way would be to, for every neighbor point, we would give at least this information plus the point number. And then from that we could find the position. Because a position generator will need that. And then the normal generator doesn't really care about that. It just looks through the neighboring points and will somehow get an average normal from that. Okay, but I think that information is only needed by the position generator, so maybe we'll just tie that into that. I don't know. We'll have to think about it. Okay, so let's see. For neighbor points. Because the whole point is that I want a section to never have to look into the data of another section because we're trying to multi-thread this. And so I won't know for sure which sections have already been set up. So we're gonna, there'll be a little bit of like duplicate logic, but I guess the other thing that could happen is the position generator would only run once all sections have been set up. No, I don't think that's not a good idea. All right, so just trying to think what's the best way to do this. Well, I guess I don't really have any other option than to specify that information. So I guess this would be the section type, side index, and then point index in that section. And then from there, it would just like feed this information back into itself. And then it would resolve this point index with this algorithm. And so yeah, this part would exclude neighbors. Okay. I think a neighbor graph would still be useful because I'm going to because like we won't really know. Well, I guess we would know at this point, but we won't know for sure just if we have any point given in this array. There won't be a way to figure out which indexes are its neighbors because each neighboring section has like a different arrangement of points, so the lengths of those arrays would be different. Yeah, this okay. This is a lot more complicated than I was bargaining for, but okay. So we know how to figure out the positions. That's pretty easy because we can take just the arrangement of points and then this information that the topology gives us and figure out all the positions pretty easily. The normals, well, that's the whole reason we need to know the neighbor points. Do I want to do this, or should I just have the normals run like per chunk? And so and then once an entire all the sections are done, then the normals, I think I might have to do that because the normal depends on separate sections. And having to store all this information, I think, is just going to make it more complicated. Yeah, so, okay. Well, that actually won't... I was afraid that that would slow down this algorithm too much because anything that runs per chunk would have to wait until all the per section systems are complete. But what I can actually just do is have the normal generator run at the very end, right before the visual mesh. Yeah, so let's move that down. So this will actually run per chunk, and it will need the section, topology, and visual mesh positions. Okay, so yeah, at the first, the section generator will run per chunk, and it figures out all the sections we'll need. And then the topology runs, and the position and triangle and blend generators can all run at the same time. And then, so can the collision triangle generator I might want. Oh, no, it can run at the same time too. And the normal generator runs when these are done. And then this runs when the normal's done. Okay, so I think that's the best way to do it because the normal depends on stuff that's outside of the... Yeah, outside of a section, so that will make this a lot easier. I don't think I need to do that. And now topology, like every point that's in here would be owned by this section. Okay, so now the only other question I have is, should the terrain blend and the position generator be duplicate RB together now, because this will also output the terrain. Yeah, because the position generator needs to know that before it runs. But the terrain, the blend generator. Because this information is basically just the lerp values, and the position generator already knows that, so they're kind of intricately linked. So I think I will just have them at the same time because we'd be duplicating a lot of logic. Alright, and the cool thing about this is that, for instance, during the game, if we only changed one chunk, anything that, or one block, anything that runs per section would not have to run for the entire system, or for the entire mesh. So, like for instance, we could save a lot of these section datas, and then just the per chunk, and then the per section ones would only run on those specific sections, and the per chunk generators would only run on the chunks that have been changed. So that would be nice that we kind of have that built into the system already. Alright, so I think that's enough theory crafting. Let's try and jump into it. So, like, unfortunately, as I've said before, I don't have an entity component system just yet, so I'm going to try to fake it. So we'll just put everything in this transient state. Okay, so I'll have, where is this defined? Oh, up here. Let's rename this to terrain chunk. I guess I don't really need to do that because it's in the terrain namespace. That's kind of assumed. And then this would be a section. Okay, so I need to have the section type. So we'll have the hex face, which is the top of a hexagon, and then the margins are where it gets a little complicated, but we'll have the rectangle. I think I'll call this a spanning rect margin, and then a spanning try margin, because when I add in visible blocks that are below the surface, these margins might actually be split up. And one thing I want is for the section, everything in the section to share vertices and have the same terrain variable. So that will just simplify that, I think. Okay, and then we need its the chunk it belongs to, and then its index. I guess I'll call this the hex index. And the side will be for margins, and then well, I'll wait to deal with the sub margin types, because for instance, if we're splitting the margin between two blocks, then we'll need to have like a margin index, but we won't need that just yet. Okay, so what else is on this section? It has this topology information, which basically just has wait. It really just needs to have the number of points. Number of points, and then I don't know, point arrange data, which will be different per type. as we defined here. Okay, and then this is information for the visual mesh, and so they're all constant as well, so I can have just normal arrays. This will be a vector 3 positions. Oh, I said vector 3, but I wrote 2. Normals. Blends. And then just a single vector 3 for the terrain. I feel like I'm forgetting something. Oh, the triangles. Okay, and one interesting thing here is that the triangle indexes will be in local numbering. So for instance, we won't have a chunk-wide triangle index here. That will have to be generated later. And it's not that difficult, so it will work out. Alright, so this chunk state... Yeah, I really don't like having to do this for the states, but there's no better way. I guess I need to have this ready stuff here as well. Okay, so we got topology. If I can spell it right. Positions and triangles, I think. And I'm kind of ignoring the collision right now, actually. But because I'm not sure, we're going to need to test it. I could have the collision, for instance, use perturbed positions, in which case I'd want it to run after the position generator, or I could just have it used the standard positions like we do now, in which case it could run directly after the section generator. So yeah, I'm not going to worry about the collision right now because it's like a separate line in the generation, so it's not going to cause much issues, so we'll just do it later. So what else? Okay, so we got the section generator and the normal, and then the visual mesh that runs here. Oh yeah, I should change this. Let's like just put state at the beginning. Oh. And then I'll just say S visual mesh. Okay, and there'll be a list of sections because yeah, we don't really know how many sections there will be until after this controller runs. Although I guess at that point it could just insert it into an array. I don't really know if it matters. Okay, and in that case I don't really need to have this separate chunk class. Yeah, this should just go in here. We don't need the blueprint anymore. Okay, and again, I'm just not going to worry about collision. We'll do that later. Although, like I said, it's going to be pretty simple. Because it doesn't have normals, and that seems to be the complicating part. But let's leave this as a list. Although really, I can't ever see the number of chunks changing mid-game. But alright, so I think I've got the data complete. No, do I? I'll have to do a little bit of updating here probably. Oh yeah, so I just changed this to chunk. Okay, so if it's redoing it for now, we'll just kind of reset this. I'll just have a clear function. Doesn't exist yet, but that's not it. And we'll just set sections to null and graphics mesh clear. Although graphics mesh might not have been created yet, so graphics mesh does not equal null, then we'll clear it. Although I guess that's not really needed because we already called the already have this clear chunk variable, which I think I can just change that to state chunks, and then I can get rid of that. Okay, and the point is that this was also supposed to reset all these variables. It's idle, normals equals idle, and equals idle. Okay, and now this would want to set those to waiting to say that they all need to run. And there's a much better way to do this, like whenever we get the new Unity's job system. I'm kind of trying to write this code as job ready as possible. So that's why some of this is a little clunky right now. Alright, so if this would be when everything is done, so that'd be when all the, for now it's when all the visual mesh is done. Yes, visual mesh equals complete. Oh, it's supposed to be does not equal complete. Okay, and I can just get rid of that. Oh yeah, there's no collision mesh right now, so I'll just return null. Okay, so let's get started. I know I just created this before, and I guess we'll leave it for now, but we're actually not going to use that code. I want to have the section gen system. And this will generate all the sections in the chunk. No, it doesn't need to be public. And this is an what did I call it? Terrain mesh builder. Okay, that just has an update. What would we need to send here? Well, we just need to have information about its specific, or the list of chunks. At least that's how it would work with a real entity component system. So I guess we'll just need the terrain state for now. Oops, no equals there. We might also need the board. Actually, we'll definitely need the board. So we'll need the game data and also the battle. Okay, I'm not gonna keep this standard. I always call it the database. Oops. And this dot battle equals battle. I always make the constructor first, but I really should set these variables first because then I can automatically generate this constructor. And that would speed things up a little bit. Alright, so if state dot... Okay, well we need to loop through every chunk. So for int I equals 0, I less than state chunks. Or it would be state num active chunks. If state chunks I dot s sections is waiting, then we'll what should I call this? I guess run. Oh, if I can actually type, and then I'll just pass the index. All right, and so again, what we want to do here is the section generator doesn't depend on anything in here, but it can depend on outside data. It's no big deal. And then it needs to output basically all this identification information from the section. And also, it should create the sections themselves. I should write that in. Outputs section entities as well as this information. Let's just shorten this to the identification. I did forget something. Okay, so we know there's going to be one section for each hexagon. Actually, if we look in our graphics mesh generator, pretty much we'll want to just use this function. The blueprint doesn't exist anymore, but I just figured that's not what we don't need it anymore. The topology generator does that. Okay, so yeah, we need to loop through every hexagon in this chunk, which I guess we might need to look in the old blueprint builder to figure out how it did that. Okay, and the reason it adds 2 is because it also contains the neighbors. Okay, we're bringing... that's... I forgot about the borders between the chunks. That's another issue with these confounding normals, because it also will need to know, since it needs to know neighbors, it might need to know information in another chunk. So really this normal generator needs to run like for the whole terrain. Although it is like considerably easier if we just... Well, I don't want to duplicate generating whole sections. That's pretty wasteful. Okay, but if the normal generator runs for the entire terrain at one time, it can be parallelized, but it just needs to... Yeah, we can still like run multiple jobs. The jobs just need to know information about the whole map. So really, this needs to wait until everything is done. So this... let's see. This would be per terrain, I guess. For all sections and all chunks. Okay, and then I guess note that this can still be parallelized. I think I spelled that right. I always forget if the double L is the first one or the second one. Neither looks particularly correct. Okay, it's gonna bother me unless I figure this out. And of course I made a typo. I was trying to figure out the spelling. Okay, so yes, the first L is double, so that's correct. On a per point basis, but it needs the entire terrain to have... It needs point or positions for the entire terrain mesh. Okay. Yeah, I don't think there's any way around that. It's kind of a bottleneck. But I guess it is the last thing that runs, and these mesh generators are going to be kind of simple, so... yeah, we'll just have to run with it. And we can still have it only run on sections that have actually changed. But yeah, we'll figure that out when the time comes. Okay. So what am I looking at? Sorry, I got lost in thought there. I guess we'll just need this information. Yeah, because this is like the number of cells in a chunk, which is what we'll need for the section generator. Okay, yeah, so that's the number of chunk columns. Then the number of rows. Excuse me. Allergies have been bad lately. Okay, and then yeah, we'll have this number of cells, except yeah, I'm not going to include neighbors. Okay, well I was just thinking that like to figure out the blends, we'll need to know the terrain of the nearby of the neighboring hexagons, but that's okay because that doesn't depend on anything that's actually generated by this terrain generating system. It just needs to know the, I guess I should say block type, not terrain, because that's kind of confusing. Yeah, because that was the whole reason that I had added the neighbors to the chunk generation here, but it's not needed anymore, I don't think. Yeah, that pretty much would just be, yeah, for the position generator when we figure out the blending. Or actually, no, it doesn't even need to know that. It's only when the topology generator needs it to figure out the terrain, and it runs, oh, it doesn't run per section. That's okay because it's not like, it doesn't need anything that's generated in a separate section. Anyway, so yeah, for int 0 less than num cells. I think I'll rename this to just hexes. I had cells because I wanted to differentiate it from a block, which a block is like in 3D space where a cell was in 2D space, but I think hexes makes more sense. And then we'd put this inside there. Okay, I thought I already updated this to take out this third argument. I guess that was in this part. So if I just copy that. Then I need to change cell index to H. Oops, I don't know why. Okay. Oh yeah, I need to put some in backwards order. Okay, so this needs to know the row for the surface. Why does it need to know that? Oh, well, obviously it just needs to know the row, but we don't have to call surface block for that. That's true. I guess the topology would figure out the surfaces. Although, wait. The section will need to know that because it will need to know, again, when we show terrain that's below the surface, it would need to break up those margins, so it would need to know what the highest block is and things like that. Although I don't think anything else depends on that except maybe the position. But anyway, we can figure that out as needed. Okay, so to find the row, that would just be the start row. Okay, yeah. Okay, so the whole row is... We want the row in the whole board and not the row in the chunk, so... Is number of rows times... Oh, we already have that information here. We have the start row and the start column, so... Plus h, I guess, divided by the number of columns. And then this is h mod the number of columns. Alright. Yeah, because we only need to create these specific margins if we're at the end of a row, otherwise they're taken care of by the next hexagon that comes after us. Okay, so a hex face is pretty simple. Okay, so I think in the state, excuse me, I have it as an array of sections. I think I might actually change it back to be a list because in the final, using Unity's entity component, it would be something like just add a component, and so I wouldn't need to try to keep track of a list and then convert it to an array. Yeah, so I think this will be more like the final system. Alright, so I guess I'll just have a function that's like add section. Or I shouldn't do that, I should just pass the information needed, so section type x index side, is that it? And I guess a chunk, although I should probably just store that unless I want to pass that through to each. Let's rearrange this a little bit. Well, side is more optional, so yeah, I'll put it at the end. Okay, so I guess I will pass the chunk through. I'll copy the comma. And then change that to hex, index. Oops, wrong spot. Okay, so let me see here. New, or I guess yeah, we can do it here. So this would be state chunks, chunk, sections, add, new section. Then I just need to fill in all the types here. And I think that's it. Okay, so for this I can just do it easy. Add section, chunk, x index, and then type x face, and side doesn't matter, so I'll just do -1. And the margin rect also is simple. Later on, when I add, I've got subdivided margins. This will be a bit more complicated, but where's the side variable? Is that what this v is? Another way, again, would be to count out the margins and just have like a margin index, but I think still specifying it by the side is the easiest way to deal with it. And this is the same. Okay. I think that's it for that. Excuse me, I don't know. Something keeps getting stuck in my throat. Okay, also, I forgot I need to move this normals out, because the normals actually runs for the entire terrain now. Okay, so let's get rid of that because, yeah, we're basically starting kind of from scratch. Really just rearranging everything. Systems. Add new section. Gen system. So database, battle, and state. And let's simplify the map generation. Let's just move it down to one chunk, so be 4x4. I think this should all be okay, so I'll leave that. And then what I'll want to do, Oh yeah, I need to change these also for the sections. When I add them here, so let's see, this would be S positions is weighting, S triangles weighting, and topology weighting. Everything else stay default values. So what I'd like to do now is make it so this terrain mesh data is visible in the debugger, so I can actually see what values are being put in here. Okay, and I think I'm gonna have to make these public. Okay, as far as I can tell, I think all this will work. Just by default in the our little debug system I have set up so far. Okay, so the terrain. Okay, and I can't just get it because the terrain is not a component. So let's kind of do something a bit hacky here. Definitely want to take that out later. Equals get beluga comp terrain mesh. Okay, so that should work. Let's see if it pops up right here. Well, it won't because we have errors. I think I'm just gonna comment out these functions for now. Or these classes. Because I don't want to delete them because we might need it later, but... Actually no errors here, so that's fine. Point generated system. Webcam is a bit high, isn't it? There we go. Okay. I commented that out though. Oh, I forgot to save. Okay, now it's recompiling. This is saying that a lot of information is not used. Oh, because this blueprint cell I should just get rid of, but okay, here's the terrain, so we've got chunks. If I just add one. Just to make sure this works. Yeah, so I can see everything. Alright. Then... yeah, I can get rid of all this too. Although that's definitely gonna make the graphics mesh generator complain. Okay, so I'm gonna play and let's just see if the sections that are generated actually make sense. Okay, we got an error. Text buffer too large. Okay, so apparently we crashed the UI system with this. Oh, 1,333. Or that can't be right. The map is 4x4, which is 16 hexagons. I did save it, right? And then at the most, that would be 16 plus. At the most, there's 12 margins, so that'd be 12 times 16. Maybe that is correct. No, is that right? Yeah, that's not 1,000. Where's that coming from? Okay, so running once per chunk. Oh, I didn't set this to complete, so it was running over and over again. State chunks I s sections equals complete. Okay, yeah, this makes more sense. 89. It's a hex face, and then, yeah, spanning rect. It's interesting, there's no triangle. Okay, there's a triangle. And the very last one should probably be rectangle. It looks like it makes sense. Okay, so now the next part is our topology generator, which just takes this basic information that the section generator gave us, and then we're going to output topology, which is really just the number of points in each section, and then some pretty standard information about how they're arranged, and also the terrain. Maybe I won't call it the topology just because I don't know if that's the correct term. Let's just call it the layout gen system. I need to get a drink of water. There's something in my throat. Wait, that feels a little better. Okay, so this again is an terrain mesh builder. At the very least, we'll need not public, private, the terrain state, game data, because we'll need to know the block prototypes, and I guess we will need the board because we're going to need to figure out the height of the or the altitude of the surface block for each hexagon. If I press Alt Enter, I can generate a constructor. And then also want to get update. Okay, so for int C is 0, so for every chunk And then we'll want to also loop through every section in this chunk. Actually, I'm gonna need to access this section quite a bit, so I think I'll pull that out. Or wait, first I gotta pull out the chunk. Alright, so section S topology, and I'll rename this to the layout. Is waiting, then we'll want to run on chunk section S. And then I'll just set S layout to complete. Actually, I might just pass the section object here. Because once we use entity component system, we'll actually get, it'll just be a list of sections, like they won't be inside the chunk array. That's why I have the chunk number inside the section object. All right. Okay, so what? Well, this isn't really too difficult. I guess I will do a switch on the section type. Because it'll be, yeah, pretty different depending on the type. Okay, so for hex face, we pretty much already figured this out. And here, I think I updated it. So what I need to know is really just the number of total points and then the number of points on an edge of the hexagon, and that should be enough information for anything. Oh, and the number of rows, so... let's just move this over one by one. Oops, wrong thing, I need to alt tab there. So number of points and... okay, I keep alt tabbing systems when I just need alt tab script. Oh yeah, that should actually stay a comment. Okay, so I don't really need to have this in multiple places now, I don't think, so... okay, and then on the outer edge is this num and wedge. Oh, that's the number and the total. So number on the outer edge, we can just get by the hex subdivisions because every subdivision adds 1 point. So when this is 0, it's 2. So the number of point rings is actually equal to the number of points on edge. It's the same, but I think I'll write it out. This class should probably be some helper function because, yeah, later on we'll also, this will need to be used unless in the layout array I also have like the number of points on each ring, which I guess might not be a bad idea. Okay, so let's see. Let's change this to layout. Oops, that's not what I wanted to do. I thought I would have a replace, but okay, so for our hex face, I guess we might as well specify it here, someplace standard. Or maybe do it in code, I don't know. Where is the state? So basically, I'm trying to decide how I want to encode this array, which should actually be an array of integers. I guess this can be separate because this will be something everything will have. So yeah, the arrange data. First one will be number of point rows, and then points on row 1, dot dot dot, points on row n, which is the last row. I think that'll be easy because that way the other classes won't have to know this counting logic. Okay, so if that's the case, then the point layout is the number of point rings plus 1. Then the 0 is the number of point rings. And then for int I equals 0, I less the number of point rings. Section point arrange data I plus 1 is the number of points on a ring, which is 1 and then 6 and then 12, because I think it adds 6 for every one you go around, because there's 6 there and then 1 extra for each side. So it's, I think I figured this out already actually. This is like the total points. I actually want the number of points in one. So, I need to add one there. And so section, because again, the first row is 1. And then the next one is just 6 times I, isn't it? Yeah, because 6, and then add 6, 12, and then you add 6, 18. Is that right? Yeah, because this is like the... Oh, okay, I think this sequence just works out because of the way... Yeah, it's kind of interesting. So 6 and 12, and then when you add those together, it gives you 18, but you add 1 for the center. Yeah, so kind of the number of points on edge N is the same as all points on the previous edges, I think. Oh, that might not be true for the next edge, actually, because we would just add 6 to 18. Which is 24. Yeah, because we just add 1 extra point to every edge. But anyway. So I'm not sure how useful this point arranged data will actually be, but because this formula is kind of simple, but I guess it's better than having to duplicate it. Alright, so I think for now to try and get through the system as quick as possible to have something testable, I will just ignore the margins again. Alright, so terrain mesh. What am I trying to do? Oh yeah, I need to add this new system. Okay, and the order here is different, but it's okay. One other thing I need to do is I have to define the terrain for this section. And that would just be... Okay, so maybe just for ease of use... Okay, well, this is where I need to know the surface. And also the world index for that block. Can I think I could reconstruct it from the chunk and hex index, but... well, that's fine. We'd save some data instead of having to store it again, because it's... recalculatable. Okay, so I think I'll just name this, I don't know, world, actually, chunk section to world. And section, no, we can't do the section, we'll have to do like the hex. And then we'll also need the board. Because we'll need to know the size of it. So I'm going to kind of work backwards from here. So I think I'll need to know the number of columns. Okay, so I need the chunk size. Okay, so now I can just return board to. Wait, no, that's not right. So really I just want to move from the chunk index to board index. Okay, so that's just that, and then I need to... Okay, that's... So I need to convert this hex index into like the chunk row and column. Okay. Chunk row is hex index divided by number of columns, and the chunk column is the hex index mod the number of columns, and then I can just return a start row plus chunk row times the board row size. Plus start column plus chunk column. Okay, so I think that's right. We'll be able to figure it out by looking at the data. Okay, and then also I have the blueprint builder used to have the find surface, so I think I'll just lift this function out. Okay, let's change this from real to board. I think it was to differentiate from the chunk column and row, but okay, so int. Don't know this though. Probably this would be more useful if I had it return. Okay, this would be calculate index. Then I'll have calculate, I don't know, position, which will return a vector2 int. Okay, and instead of just adding this, we'll just return new vector2 int. Okay, no, I don't need these parentheses. And I think actually this calculate index can just call the calculate position. Okay, and so this is the position dot y and position dot x. I have this inverted here, so I better fix that. Okay, so now I can get vector2 int board hex is a chunk section to world. Oh, it must be in the wrong namespace. I bet I forgot to rename that. Yeah, there we go. Okay, so the chunk index is just section chunk and then section hexagon, battle board, and database metrics. Okay, so now I have that and I can calculate the surface. Int surface altitude. Board hex.x. Let's call this get surface altitude. Alright, now that I know that, I can just set the terrain to be equal to this value. Okay, so section.terrain equals new. Well, I need the prototype index. Which is the battle.board. Oh, okay, and I need to know. Excuse me. The board index is a new X position. Board hex dot y, and then the layer is just the surface altitude. And we want to get to board index. There's a lot of converting between different coordinate systems here, but that's okay. Okay, now that will give us the surface. What's wrong with it? Oh yeah, I need to... One more. Okay, so that gives us the block prototype for this block at that position on the board. And we can just insert that into the the section.terrain. And yeah, this information or this algorithm here will also be in the calculation for the margins, but I'm not going to deal with that just yet. Okay, so now, excuse me, gosh, my allergies. Yeah, so we output the layout and the terrain, so I think we're good. This surface I might want to store in the section as well, but I'll wait to see about that. Okay, so let's see. This compiles and then I'll run it and we'll check our debug output to make sure everything makes sense. Oh, we got an error. Array index out of range. Okay. So I bet this returned -1 because it's not valid on the board. So I bet I got this wrong. Let's do some debug logs. String format chunk hex board position. Alright, let's look and see what that prints out. once it's done compiling, that is. Okay, chunk 0, hex 0. That's not right. This should also give us board position 0, 0. So let's look and see what's going on there. Okay, so the row size, that should be okay. Oh, you know what? We don't need to negate this by 1. That was for the old code where we added neighbors, so I think that's the whole issue. I should have caught that here, but now I duplicate this code. I don't know. I should probably move this out. So public static vector2 int chunk offset. I don't remember what else I need. I need the board and the metrics, so both of them. So start column and start row. Okay, so I can actually just add that to the end of here. So chunk offset. Then I can get rid of all that. And in the section index, the start row and start column. Do I still need this? No, I just need it for that. So vector2 int chunk offset is chunk section to world dot chunk offset, and I'll pass index, board, and metrics. Okay, so the row is actually the chunk offset plus r the y, and then columns are the x. Let me make sure I do that right. So yeah, column, row. Okay. I tend to invert those a lot of times. Okay, so now no more out of bounds errors, and yeah, so it's increasing on the column, and then it wraps back around when it reaches the last column, so it looks right. Okay, and then let's just check the debug and see. Okay, number of points is 37. Okay, because it says that there's 3. This seems fine, so number of points should be 7. That's actually wrong, because this should be 19. Okay, I don't know. We disconnected there. Oh, probably because we got a timeout. That's fine. To make this even simpler, let's change it so that there's only, well, no hexagon subdivisions. Okay, so the number of points. Okay, well, let's look and see what's going on. Now, it seems like it's like giving one ring too many because right now there's only 2 rings. If we look here, it's just this, so that's obviously 7 total. Okay, so when this is 0, the num point rings should be 2. So that would be 2 times... I guess I don't actually need to separate this into a different function, but might as well. Yeah, so it's 2 times 3 divided by 2 is 6 or 3, so I thought I had this math right. Okay, yeah, so this is saying this math is right because that's the number of point in each ring, which is 1 and 6. Okay, so it seems like this need to go back to point rings and then point rings minus 1. But I thought we did this before and it wasn't right, so I'm confused. But anyway, let's see. So if when this is 0, which would be the number of points... Oh, well, that doesn't make any sense actually now. Because in a hex of 0 point rings, then we'd want to return 0. But on 1 point ring, let's try that. So... Oh. That would be 1 times 0. So that's 0 plus 1. Okay, so that's right. And then 2 is 2 times 1 divided by 2. So that's 1 times 6 plus 1. That's 7. Okay, so I guess I got the offset wrong. But I thought we used to have it like that, and the math was incorrect somewhere. I don't know. Okay, but this is right, so let me add in more hex rings just to test. So now I think it should be 19? Yeah, 19, because 3 plus, or 1 plus 6 plus 12. If I add in one more, then it should add 18 to that, which... Too much math, I'm not going to do it in my head, but we'll see. Well, I guess it's not that difficult. That would be... Yeah, 37. 7, 19, then... Yeah, so 37, that's right. Okay, so I'm satisfied with that. I should have checked the prototypes to make sure that that was working right. Okay, so that is terrain 1. Then yeah, the next column is 0. Okay. Something. Oh, but yeah. Okay, the margins are confusing me. Yeah, it's hard to just look in these elements and find a hexagon. Yeah, cut the margin. I think this should be, that's a margin too. Okay, this is a hex face. Okay, so that's one. And if we look in the map generation. Okay, yeah, so if it's an odd number or an even number, it's stone. So this first one would be dirt. Yeah, that goes by row, actually. So I think it's working okay. But I guess we actually tested that here, and the board positions make sense. So yeah. Alright. Okay. So I think we're done with the layout for now. So what's next? Yeah, because we output layout and terrain, so I guess we want to do the positions. Yeah, I want to try and get terrain visible as soon as possible because that's easiest to test. So we'll do position and then triangles, and then I'll skip over the normals and just go to the mesh generator. But actually I'm out of time, so yeah, I better not start anything else. I have this, I'll just go ahead and create the new class. So position gen system. I'll work on this, and I bet tomorrow I'll be able to get terrain up and running, and maybe we can actually... Well, it's going to be difficult to do the terrain or the normals until I take care of all the margins, so... But anyway, oh yeah, I see some other little battery on this stream. Yeah, I hope that the stream avatars will be pretty fun. I know it's going to take a while for everyone to get some coins to actually customize them, but I think it should be a nice little distraction from coding all the time. But yeah, I guess I better head on out. I need to go get some lunch. But I'll be back tomorrow at around Eastern. Oh hey Hixie, yeah, that's you, alright. In a little bit, you'll be able to get enough coins to customize your little guy to look like somebody else. I think you can look at the window below the video and you can actually see something there, or you can type !avatar help for some chat commands if you're interested. But yeah, again, thanks everybody for coming by, and I'll be back tomorrow at about noon Eastern. If you want to be notified when I go live, feel free to follow me here or on Twitter. Then, of course, I have my YouTube channel where I upload all my past streams, and Discord if you'd like to chat with me throughout the day. I'd love to have you there. I think that's about it. So I'll see you tomorrow, and I hope you have a great day. Bye-bye.